What if the most advanced stealth fighter ever built isn't actually invisible? The Lockheed Martin F-35. Lightning II was designed to dominate modern airspace using stealth, sensors, and data fusion. It's often described as a flying computer, capable of seeing threats long before it can be seen. But here's the uncomfortable question no one likes to ask. What happens when radar starts catching up? Because stealth was never about invisibility. It was about delay. Delay detection, delay targeting, delay engagement. And for decades, that strategy worked. But today, radar systems are evolving in ways that challenge the very foundation of stealth design. And the F-35 sits right at the center of that confrontation. To understand the problem, you need to understand what stealth actually does. When people hear the word stealth, they imagine a jet that disappears from radar screens. That's not how it works. Instead, stealth aircraft are designed to reduce something called radar cross-section. Think of radar as a flashlight in the dark. When the beam hits an object, some of that energy reflects back. The stronger the reflection, the easier it is to detect. The F-35 is shaped to scatter that energy away from the radar source. Its surfaces are angled. Its edges are aligned. Its weapons are hidden inside internal bays to avoid creating reflective surfaces. Even the engine intake is designed to hide the compressor blades, which would otherwise act like a mirror for radar waves. On top of that, the aircraft is coated in radar-absorbent materials that convert some of that energy into heat instead of reflecting it. The result is not invisibility, but a much smaller signal. A signal that may look like noise. A signal that is harder to track. A signal that gives the pilot more time. But here's the key problem. Radar doesn't stand still. Early stealth aircraft were designed primarily to defeat high-frequency radar systems. These radars operate in bands like X-band, which are very good at tracking targets with precision. The geometry of stealth aircraft, like the F-35, is optimized to reduce reflections in these frequencies, and it works extremely well. But modern air defense systems don't rely on a single radar anymore. They use networks, multiple sensors operating across different frequencies. And that's where things start to get complicated. Low-frequency radar, operating in bands like VHF and UHF, behaves very differently. The wavelengths are much longer. Instead of reflecting cleanly off small surfaces, these waves can interact with the entire structure of the aircraft. In some cases, the aircraft itself starts to resonate with the radar wave, increasing its detectability. Now, these low-frequency radars are not very precise. They can tell something is there, but not exactly where. They cannot guide a missile directly, but they don't need to, because they are part of a system. A modern air defense network can use low-frequency radar to detect a potential target at long range. Then it can cue higher-frequency radars to focus on that area. It can use infrared sensors to look for heat signatures. It can combine data from multiple sources to build a track. This is called sensor fusion. And it's not just something the F-35 does. It's something its enemies are learning to do as well. So now the question changes. It's no longer, can radar see the F-35? It becomes, can radar systems work together to find it? And the answer is, increasingly, yes. But detection is only the first step. Tracking and targeting are much harder problems, and this is where stealth still provides a massive advantage. Even if a radar system detects something, it needs a stable track to guide a missile. It needs accurate position, speed, and direction. And stealth complicates all of that. The F-35 can exploit this uncertainty. It can change direction. It can use electronic warfare systems to jam or confuse radar. It can operate in environments where multiple signals overlap, making it harder to isolate. And most importantly, it doesn't fight alone. The F-35 was designed as part of a network. It shares data with other aircraft, with ground systems, with satellites. It builds a picture of the battlefield that is larger than any single sensor. So while radar systems are becoming better at detecting stealth aircraft, The F-35 is becoming better at managing that detection. This is the real battle. Not invisibility versus detection, but information versus information. Now let's talk about infrared detection because this is where things get even more interesting. Radar looks for reflected energy. Infrared looks for heat. And no matter how stealthy an aircraft is, it generates heat. The engine produces it. The airframe creates it through friction. Even the electronics inside the aircraft contribute. The F-35 uses several techniques to reduce its infrared signature. The engine is buried deep inside the fuselage. The exhaust is designed to mix hot gases with cooler air. The shape of the aircraft helps spread heat over a larger area. But again, this is about reduction, not elimination. Modern infrared search and track systems are becoming more sensitive. They can detect smaller temperature differences. They can track targets at longer ranges. And unlike radar, they are passive. They don't emit signals, so they cannot be easily detected. This creates another layer of challenge for stealth aircraft. And once again, the solution is not to become invisible. It is to manage exposure. The F-35 uses tactics, positioning, and electronic warfare to reduce the effectiveness of these systems. It relies on its sensors to detect threats early and avoid them. But the margin is shrinking. And that's what makes this topic so important, because we are entering a phase where stealth alone is not enough. Now let's address the biggest misconception. If radar can detect the F-35, does that mean stealth has failed? No, because stealth was never about being undetectable. It was about being harder to detect, harder to track, and harder to engage. And in that role, it still works. But it works differently than people expect. It doesn't make you invisible. It makes you unpredictable. It forces the enemy to use more resources. It forces them to rely on more complex systems. It increases the chance of error. And in combat, uncertainty is everything. Now think about this from a strategic perspective. If an aircraft can reduce detection range, it can get closer before being engaged. If it can delay tracking, it can maneuver more effectively. If it can confuse sensors, it can create openings. These advantages stack, and that's why stealth still matters. But it was no longer the ultimate advantage it once was. It is one part of a larger system, a system that includes sensors, data processing, electronic warfare, and network integration. And this is where the F-35 truly stands out. Because while its stealth may be challenged, its ability to process and share information is not. It can act as a sensor node. It can guide other platforms. It can operate in environments where traditional aircraft would struggle. In many ways, it is less of a fighter and more of an information platform. And that changes how we should think about it. And the question is not, is the F-35 invisible? The question is, does the F-35 control the fight? Because in modern warfare, control matters more than concealment. Now let's bring this back to the original claim, the stealth myth. The idea that stealth aircraft cannot be detected is, and always has been, a simplification. A useful one, but not entirely accurate. Stealth reduces visibility. It does not eliminate it. Radar is evolving. Infrared is improving. Data processing is accelerating. And as these systems advance, the advantage of stealth becomes more conditional, more dependent on context, more dependent on tactics, more dependent on integration. But that doesn't make it useless. It makes it part of a larger equation. And that equation is still being solved. So the next time you hear someone say that the F-35 is invisible or that radar can now easily detect it, remember this. Both statements are incomplete. The reality is more complex. The F-35 is not invisible, but it is not easy to detect either. Radar can see more than it used to, but it still struggles to build reliable tracks. And in that gap, between detection and certainty, is where modern air combat exists. That is where the F-35 operates, not as a ghost, but as a system. A system designed not to disappear, but to control when it appears. So, what do you think? Is stealth still a dominant advantage, or is it slowly being overtaken by modern detection systems? Let me know in the comments. And if you want to go deeper into how radar actually works, and why even the most advanced aircraft have weaknesses, subscribe for more breakdowns. Because the future of air combat isn't about being invisible. It's about being smarter than the system trying to find you.